So Friday we reviewed function notation. So we went from something that was in function form, like this. That's just a regular equation. We replaced y with something like this, f of x. Okay, these are just little examples. They don't have anything to do with these actual problems. And a few other things we talked about were that, so notice I've just replaced y with f of x. Those are equivalent forms. They tell different kinds of information, but they are interchangeable. And one thing I want you to notice here at this f of x equals y notation, and this will be something we use when I talk about number one. These mean your x and your y, the input and the output that goes along with it. So if you're looking at number, and we can do this with equations or graphs, okay, when we're trying to find the value of a function using function notation. For the graph up here, part A is asking me to find g of 0. Okay, this is a g graph, right? There's the name, g of x. This is the name of the function. The outputs depend on the input x. To find g of 0, so here's what's going on. I don't know g of 0, right? It equals something I don't know. Well, this is your x, and this is your y. So this, when you see this notation, it's saying when x is 0, what is your y value? When your input is 0, what is your output? When you're plugging in 0, what do you get back? For a graph, you don't even have to do any math. You just have to be able to interpret it and read it. So you go to the graph, you find where does x equal 0, and it's right here. It's on the graph. What does y equal right there? 0. So that's the answer. G of 0 is 0. That's your x, that's your y. Okay. The second piece asked for g of negative 1. Well, I don't know what that is. This is my x. It's asking me what is y. What is your output when your input is negative 1? Well, here's where x is negative 1. When you trace up to the graph and find where x equals 1 is on the graph, what does y equal right there? 1. So the answer is 1. G of negative 1 is 1. That's the value of the function at x equal negative 1. Part B is flipping it on you, okay? Part B says, okay, find x for g of x equals 4. So now I'm looking for x when y is 4. So I go up to the graph and I find all the points on the graph where y is 4. And there actually happens to be 2 places, right? So here's where y is 4. Everywhere here. How many places does it cross the graph? 2. One time here, one time here. So when y is 4, what is x? Negative 2 and 2. So those are your 2 answers, negative 2 and 2. So part B is x equals negative 2 and 2. So when the output is 4, what were the inputs? All right. Number 2 then has no graph. You're using the equation. And last week when we first started, the first kind of example we did when we were evaluating and plugging in stuff was something more along these lines. Like I might have said, oh, what's f of 7? And I told you, whatever's in the parentheses is what you're substituting in for x, right? And so we would take that and we would plug it in for x and we would simplify, okay? But I didn't give you 7 here. I gave you something a little bit weirder. I gave you n plus 2. Okay, it's a little bit weirder because it has a number and a variable. It's an algebraic expression. But the process is the same. Whatever's inside the parentheses is what you substitute for x. So you take all of the n plus 2, you put it there, and you put it there. So f of n plus 2 means, instead of x squared, I have n plus 2 squared. then minus 5x, but now instead of x, I have m plus 2, the whole group, so I need to put it in parentheses. Right. And then you just do the math on that. You simply follow your order of operations, you simplify. So m plus 2 squared right here, what does that mean? It means m plus 2 times itself. Okay, that's a FOIL problem. So it's not just m squared and 2 squared, it's m squared and 2 squared plus the stuff in the middle. If you were to FOIL that, you'd have this. And that's just the FOIL part. The second part of the problem, you're distributing the negative 5 to both things right here. Negative 5m, and then it's negative 5 times 2, so it's negative 10. The most common mistake I would get on this problem is a positive 10 right there, because they didn't bring the negative along. Or sometimes I just get 2, because they don't remember to do negative 5 times the 2. And then you just combine like terms. Nothing combines with the m squared. Sorry, m squared. M's are like terms, that's a minus m. And then 4 negative 10 is a minus 6. You're done right here. You do not have to factor and solve because it is not equal to 0. And nowhere in the problem did it say solve. So it just said find f of m of 2, and that's what it equals. And you can be just done. No factoring or nothing, okay? Any questions about the warm-up? Did you have a question? So your quiz Thursday is going to have this stuff on it. It's going to have everything from the new unit that we started last week. So it's got Wednesdays, Thursdays, and Fridays lesson. If you haven't done any of the homeworks and you were trying to figure out where you should spend your time most, I recommend Thursday's homework. That was the day we were finding domains from equations where we had the square roots and we were like, what's underneath has to be greater than or equal to 0. The denominator cannot equal 0. Sometimes that happened in the same problem, and we did the interval notation and the number lines and all that. We're doing that on the quiz. So Thursday's quiz, bless you, is over Wednesday, Thursday, and Friday of last week. And the warm-up was what we did Friday. Wednesday's homework was real easy. So you could probably just wing that part of the quiz. But definitely go over Thursday's homework if you haven't, and probably Friday's just to be on the safe side. Any other questions about what's on the quiz Thursday? Okay. Were there any homework questions? Here was there homework? It's pretty straightforward. Questions? Questions on the homework? Going once? Going twice? No? All right. Let's do today's lesson. Today we have, all right. So we have this 1987 LeBaron, not a piece of Chevette. Has 15-gallon gas tank and gets 23 miles per gallon. The number of miles he can drive is a function of how much gas is in the tank. Those words right there, a function of, is always your clue to what is your dependent information and what is your independent information. What comes before the words is a function of, so this, the number of miles he can drive, that's always the dependent information. And it depends on whatever comes next, which is how much gas is in the tank. That is your independent information. And we're going to talk more about that and how to use that to set up your function notation. So with your function notation, it's always, like we write it a lot of times like f of x, but just as a general rule, the letter on the outside is representing your dependent information, and the letter on the inside is representing your independent information, okay? Whatever's outside depends on whatever's inside. So let's define some variables, okay? Here I said that the dependent information was the number of miles he can drive. And it depends on how much gas he has, right? Duh. So give me a letter you want to represent number of miles he can drive. M, okay. And how about, what do you want to represent how much gas is in the tank? G, okay. So my next question is, I'm going to give you two options. If I was starting to build my function notation, I would either need to write M of G or G of M. And keep in mind that the letter on the outside depends on the letter on the inside. Do you think here that that would be option 1 or option 2? 1 or 2? What did you say? 1, right? Option 1. Okay. The miles he can drive depends on the gas that he has. How much gas? So this will start our function notation. And now we write an equation to represent that concept. We know there's going to be a G in there somewhere because that's our variable. But we have these other two pieces of information. We have that he has a 15-gallon gas tank and that he gets 23 miles per gallon. Which of those is relevant right now when I'm trying to figure out how far he can drive depending on his gas? Is it his 15-gallon gas tank or that he gets 23 miles per gallon? Which one will determine how far he can go based on how much gas he has? Tell me what M stands for again. Miles he can drive, right? So if I had a car and I was trying to figure out how many miles I could drive at any given time, does it matter to me the capacity of my tank, that it can hold 15 gallons? Or does it matter to me how many gallons I have at any given time? Like which one? To determine how far I can go. So to figure out how many miles he can drive, it's 23 miles times however many gallons he has. Okay? And we don't know that, so that can change, right? And that's why it's a variable, because variables vary, right, or change. And so that's our function with function notation. And then part B says, okay, determine a reasonable domain and range in this context. Now, usually when we talk about domain, we say, oh, hey, you know what? Domain is all the x values. And we're not using x here because we're trying to make our letters represent the situation. So, but this is one thing that's always true about domain. It's always the independent information. Which letter did we use for independent stuff? The G, okay. So my domain is G information. It's the range of values I could have for the gallons of gas. It's my lowest to my highest possibility. What's the least amount of gallons that this kid could have? 1? Could he have less than 1 gallon? So what's the lowest he could have? 0, right? That's the lowest amount in the domain. What's the most amount of gallons he could have? 15, right? And that comes from the problem. And would these have parentheses or brackets? Brackets, absolutely, because he literally could have 0 gas. Hopefully he's at the gas station if he's at 0, literally. And he could literally have 15 gallons. He could be all filled up, okay? And so those get brackets because they are included information. It could actually equal that. And so that's your domain. The range, usually we say, oh, hey, that's the y values. Or the dependent information, depends on whatever your domain is. In this case, it's M, or M of G. It's the miles he can drive, okay? That depends on however much gas he has. And so the lowest value in the range depends on the lowest value in the domain. It's whatever m of 0 is. Now, I know you don't need an equation to tell me if you have 0 gallons of gas, how many miles can you drive? 0, right? But just to practice our function notation and our plugging in, m of 0 means plugging in 0 for g, which is 23 times 0, which, to no one's surprise, is 0. Because you have 0 gallons of gas, you're going to drive 0 miles. And if he had a full tank of gas, so this is his upper range that he can drive, or m of 15, 345. You plug in 15 to your function. I know you're not going to sit around writing equations in your car when you're running low on gas, unless you only have like $5 and you want a soda and you're trying to go to Austin for the weekend. You might do an equation and see if you can afford the soda, if that's all the money you have. So that's the lower limit, that's the upper limit. To write that in interval notation, your range would look like this, 0 to 345, definitely with brackets because you can actually do that. Those values are included. Okay, so again, I know that seems like a lot of unnecessary writing. You could have solved that problem probably with your eyes closed. But again, it's a simple problem so that we can practice our function notations, how to write the intervals, how to write dependent and independent information, etc. Okay. Anybody need any of this up anymore? All right. So the next problem is about male whales. Everybody say male whales. That was fun, right? That's good. The ideal weight for an adult male can be modeled by this function. W of h equals 9/2 h minus 151. I think it's fabulous that we live in a world where someone loved whales so much that they gathered all this data to come up with this mathematical model to figure out so they can, I don't know what, optimize their lifespan, so they can be around for their children and not have a heart attack from too much fat. But isn't that what whales are known for, right? Blubber, right? It's good for them to be fat, right? I'm not exactly sure. I guess they can have too much fat because we have this equation that represents their ideal weight. So we have this function. It's written in function notation, right? The thing on the outside depends on what's inside. So the weight depends on the height. I guess it's a BMI for whales. Where W is the weight in pounds and H is the height in inches. So part A says, find the ideal weight for a male whale who is 75 inches tall. How are you going to do that? Part A. Find the ideal weight when you know the height is 75 inches. What math are you? Plug it in, right? Plug it in, plug it in. And because we're practicing function notation, I'm going to be very teachery and write this. You're finding W of 75. That's what you're finding. So take a minute and do your math. Isaiah, did you get an answer yet? Did you get an answer already? No? Tell me what your answer is after you get your answer. Please. Please and thank you. Josiah, what'd you get? 186.5? Yeah, very good. 186.5 pounds. That is the ideal weight for this whale. What do you think about that? That's not a very big whale, right? 75 inches, how long is that? Yeah, 6'3", 186. This whale could fit in the disc, right? It's like a man. It's like a kind of tall man who's pretty decent weight. So it's a baby whale, I'm thinking, right? A baby whale? A baby male whale. So part B says if a male whale is 72 inches tall and weighs 210 pounds, how much is the whale over its ideal weight? This poor male whale is going to have an eating disorder because it just told there. It's going to be told it's overweight. So this is a two-step problem, all right? What would be the first thing you need to figure out? Its ideal weight using that function right there. So the first thing you need to find is the ideal weight, which means, since I'm being all teachery and using function notation, you need to find W of 72. And then once you have that number, what are you going to do? Yeah, subtract it from 210. So go ahead and take a minute and do that. And don't let your conscience bother you that you're going to tell this whale, this baby whale that's fat. When it's obviously still a baby, that's like the worst time. That means plugging it in 9/2 times. Matthew, what'd you get for this number, please? 173. And then you did 210 minus 173. This baby is 37 pounds overweight. But you know what? As long as his blood pressure and cholesterol checks out, he's okay. All right, you may go to the bathroom. Please drop your phone, sign out. And I have your homeworks for you. You may have your music while you work.